Now let us discuss the activity of establishing product specification through an example. Assume that a company is manufacturing a bicycle for a wide range of the customer. Now it is interested in developing a new front suspension fork for the mountain bike market. Although the firm was already selling suspension normal forks on its bicycle, it was interested in exploring the designs that would provide better performance for mountain bikers. The development team has already spent a great deal of time in identifying the customer's need. In addition to logging many hours of riding on suspended bikes themselves, the members of the team have interviewed lead users at mountain bike races and recreational cyclists on local trails. And they have also spent time working with the dealers in their store. As a result of this process, let us assume that they have assembled a list of customer needs. Now you have to establish the product specifications for new fronts. This figure depicts some example of the front suspension forks available in the market. The name of these models are ST Tri-Track, Manure 2nd, Rockstax Quadra, Rockstax TI-21, Tonka Pro, and Gunhill Headsaw. As discussed earlier, establishing target specification is a 4-step method with iteration. Now we will discuss each step with respect to establishing specification for front suspension fork of a mountain bike. The procedure for establishing target specification consists of following steps. The step first is to identify a list of the metrics and measurements units that sufficiently address the need. In the second step, we will collect the competitive benchmarking information. Afterwards, we set ideal and the marginally acceptable target values for each matrix or the performance indices. And finally, we will be getting the reflection on the results and the process in the establishing product target specification. The tasks start with identifying the customer needs. Customer needs are generally expressed in the language of the customers. The primary customer needs for the suspension forks are listed herein. Customer needs such as the suspension is easy to install, or the suspensions enable high-speed descent on bumpy trails indicate quality of the expressions. Such expressions are helpful in developing a clear sense of the issues of interest to the customer. They provide little specific guidance about how to design and engineer the product. For this reason, the development team usually establishes a set of specifications which spell out in precise, measurable detail what the product has to do. Product specifications do not tell the team how to address the customer needs, but they represent an unambiguous agreement on what the team will attempt to achieve in order to satisfy the customer needs. For example, in contrast to the customer need that the suspension is easy to install, the corresponding specification might be that the average time to assemble the fork to the frame should be less than 75 seconds. All customer needs are herein are sorted according to its importance, with 5 being assigned for the maximum preference and 1 represent the minimum preference. As discussed in the previous slides that the design teams have already interpreted the customer's needs, now they have to establish a performance matrix, which will be the first step in the procedure for establishing the target specifications. There are 2 methods to perform these activities. The first method is to list down the various metrics or the performance indices of a particular product. And in the second method, we will establish a mapping between the customer needs and the performance matrix. The first method, the list of metrics, is depicted in this figure. In the list of metrics is a good method to generate specification list considering each need in turn and to consider what precise measurable characteristic of the product will reflect the degree to which the product will satisfy these needs. The second method, that is the need matrix method, is shown in this figure. In this method, we map each need with the section or with the matrix performance indices through the matrix. However, the relative information regarding importance level of a particular need is lost here, but we can insert 1 to 5 dots at a particular matrix to quantify the importance of a particular need. Now we will be proceeding with the second step of the establishing target specification, that is collecting the competitive benchmarking information. Now we need to perform the benchmarking of all available suspension forms in the market. In this figure, the competitive benchmarking has been performed based on the customer survey on perceived satisfaction of a particular need. Scoring more dots correspond to greater perceived satisfaction of a customer need. This figure shows alternate method to perform competitive benchmarking based on chart matrix. The column of the chart corresponds to the competitive products, and the row are the matrix established in the step 1. The benchmarking chart is conceptually very simple. For each competitive product, the value of the matrix are simply entered down a column. Gathering these data can be very time consuming, may even involve purchasing, testing, disassembling and estimating the production cost of the important competitive products. However, this investment of the time is essential, as no product development team can expect to succeed without having this type of the information. The next step is to set ideal and the marginally acceptable target values for each matrix. In this step, the team synthesizes the available information in order to actually set the target values for the matrix. Two types of target values are useful: an ideal value and a marginally acceptable values. The ideal value is the best results that the team could hope for. This will be the best design. The marginally accepted value is the value of the matrix that would just barely make the product commercially viable. Both of these targets are useful in guiding the subsequent stages of the concept generation and concept selections, and for refining the product specifications. The final step in the procedure for establishing the target specification are to reflect on the results and the process. In this step, we analyze the outcomes of the earlier steps. The team may require some iteration to agree on the targets. Reflection after each iteration helps us to ensure that the results are consistent with the goals of the project. Once the targets have been set, the team can proceed to generate solution concepts. The target specification that can be used to help the team select a concept and will help the team know when a concept is commercially viable. As discussed earlier, setting final specification is a 5-step method with iterations. We will discuss each step with respect to setting final specification for a front suspension fork of a mountain bike. The first step is to develop a technical model of the concept. A technical model of the product is a tool for predicting the value of the matrix for a particular set of the design decisions. In this step, both analytical and a physical model of the product is developed to test performance metrics. Models are used to assess technical feasibility of the product. In this figure, the team have chosen an oil damped coil spring concept for the suspension fork. The design decisions include details such as material for the component, the orifice diameter, the oil viscosity for the damper, and the spring constant. Such models can be used to predict the product performance along a number of the dimensions. The output of the models are the value of the metrics such as attenuation, stiffness, and the fatigue life of the. The next step is to develop a cost model of the product, that is to perform a bill of the material. The goal of this step is to make sure that the product can be produced at a cost at which a company and its distribution partners can make adequate profits while still offering the product to the end customers at a competitive price. For most products, the first estimate of manufacturing costs are completed by performing or by drafting a bill of materials and estimating a purchase price or fabrication cost of each of the part of a front suspension fork. A useful way to record cost information is to list figures for the high and the low estimate of the each items. This helps the team to understand the range of uncertainties in the estimates. The bill of materials is typically used iteratively. The team performs a what-if cost analysis for a set of the design decisions and then revise these decisions based on what it has learned. The third step in establishing the final specification is to refine the specification, making trade-off whereas necessary. In this step, the team converges on the specification that will most favorably position the product relative to the competition and will best satisfy the customer need and will ensure adequate profits. This step is done through competitive maps. The map is simply a scatter plot of the competitive products along two dimensions selected from a set of metrics and is sometimes also known as the trade-off map. The map displays here so estimated manufacturing cost versus score on the monster test for concept A and B to be developed by the company. The result defined by the marginal values and the ideal values of the specifications are shown in the map. This map is particularly useful in showing that all the high performance suspensions having the low monster scores have high estimated manufacturing cost. Armed with technical performance model and a cost model, the team can assess whether or not it will be able to beat the trade-off as shown in the competitive figure. This is the reason where the trade-off will be achieved, or we will set our product specifications. The next step in setting the final specification is flow down the specification as appropriate. This step is generally used while setting specification of a highly complex product consisting of multiple subsystems or subassemblies. The different subassemblies are designed by multiple development teams. In such a context, specifications are used to define the development objectives of each of the subsystems as well as for the product as a whole. The challenge in this case is to flow down the overall specification of product to specification for each subsystem. For example, the overall specification for an automobile contains metrics like fuel economy, acceleration time, and turning radius. However, specification must also be created for the other various subsystems that make up an automobile, including body, engine, transmission, braking system, and the suspension. The specification of the engines include metrics like peak power, peak torque, and fuel efficiency at peak efficiencies. These specifications must also be represented in the overall specification of the final product that will be the automobile. The last step in establishing the final specification is to reflect on the results and the process. The specifications are considered to be final after this step if it results in an economically viable product. For that, the management team seeks answers for questions such as: is the product a competitive or a winner? How much uncertainty is there in the technical and the cost model? Is the chosen concept by the teams best suited for the target market, or would it be best in another market? Should the firm initiate a formal effort to develop better technical models? If the developed product specification positively reflect answer to all these questions, then the established product specifications are assumed to be final. Otherwise, iterations are required in the previous steps. Now we will discuss some of the technical terms used in the benchmarking and established product specification. First is the profit margin. Profit margin in benchmarking and establishing product specification is described using this expression. MB, the gross profit margin of a stage in a distribution channel. P is the price charged to a customer in a particular stage, and C is the cost at which a product is sold in a particular stage. The target cost C in the benchmarking and establishing product specification is described by using these expressions. Here P is the price paid by the end user, N is the number of the stage in the distribution channel, and MI is the margin, profit margin in the ith stage. So far we have completed the benchmarking and established the product specification for front suspension fork of a mountain bike. Now one exercise you need to perform, that is benchmarking and establish product specification for a ballpoint pen. First you need to identify 5 possible metrics and their values for the customer need, that is the pen should write smoothly. After that you have to perform the complete benchmarking and establish product specification as discussed earlier. In this lecture we have learned 2 activities, that is benchmarking and then establishing product engineering specification. First we have established the target specifications, then we have finalized the specification. In the next lecture we will start with how to generate the product concepts. With this I close this session. If you have any query you can write in the comment sections. Thank you.